Let's see an example of binomial distribution Python code. So here we are referring example given in probability notes at page 186, where we are assuming that we are creating 30 samples a day in a workshop and chance of being defective is 0.1. So in the first code shell, as you can see, we are importing few libraries such as we are importing stat module from SciPy. SciPy is a library used for numerical and technical computing, and it is built over NumPy libraries, and the stats module is where the statistical distribution of different functions are implemented. Then we are importing pandas as PD. Panda is used for data analysis, and then we use a matplotlib.pyplot as PLT, which is used for plotting functions, and then we are using Seaborn as SNS. So Seaborn library is built over a matplotlib library, and it is used for data visualization, and it can work with very closely with pandas data structure. In next code shell, we are computing the probability of 5 defective items as given in the problem, and so n is assigned to 30, and p, the chance of being defective, is 0.1, which is in term of probability of binomial distribution can be termed as success. So we are computing probability of exactly 5 success with the function binomo.pmf from stat module, and then we compute the mean and variance for this distribution and print their values. So we can see the probability of exactly 5 success or 5 defective item is 0.102, and the average for this distribution is 3 and variance is 2.7. If you can recall, the distribution average for binomial is NP, which is where n is 30 and p is zero point 0.1, so we get exactly 3, and variance is npq. So where n is 30 and p is zero point 0.1 and q is zero point 0.9, uh, 0.9 for failure, so we get variance exactly 2.7. In next code shell, we are computing binomial probability mass function for each possible value of success, or you can say count of failure. For doing this, we are using the range function, which creating exactly n objects from 0 to n, and then we are creating calculating probability binomial probability for each x, and then we creating a data frame with a variable binomial underscore df, where we have two column. One column is termed as success, where we store the value of x or the defective count, and probability, where we store the corresponding binomial probabilities. And in the next column, we are creating bar plot with Seaborn library. We choose the figure size as 10 inches wide and 7 inches in height, and then we use a bar plot function from the Seaborn library and assign the x-axis to the success column and the y-axis to the probability column, and give the label to x and y axis and use the show command. So it is our plot for binomial probability, and we can see exactly that this plot is peaking at 3 when the number of defective items are 3, which is in agreement with our theory. Thank you.